We're going to do a simple t-test on a sample of vigilance data. These data, some of the data were collected in the morning, some collected in the evening. The values that you see here are for vigilance. And what we're going to do now is simply get Excel to perform that t-test for us. The null hypothesis in this case is that there is no difference between vigilance in the morning and vigilance in the evening. Because of that, we have a two-sided t-test. That is, all we're saying is that for the null hypothesis there is no difference. For the alternate hypothesis there is a difference. We will attempt to reject the null hypothesis. We don't care if the evening vigilance is greater or less. At this point we're just asking the question, are they different? So in order to do the t-test, we're going to click on the Data tab up here at the top, and then go over here to Data Analysis. If you don't have the Data Analysis toolpack installed on your copy of Excel, you will have to do that. So we click on Data Analysis, and that little box opens up here, and we want to scroll down until we see the t-test. There are a number of t-tests. We are not doing a paired two-sample t-test. Our observations are not paired. They weren't from the same animal or collected at the same time. We're going to do a two-sample t-test assuming equal variances. We have no reason to think that variability in the morning is different than variability in the evening, so we'll select that. We click OK. Now we're going to select our observations for group 1, so let's highlight group 1 and hit enter, and now we'll do the same thing for group 2. Hit enter. Now we're going to specify the output range, so make sure you click the output range, and we're going to use that right there. That's fine. And now we clicked OK. Let's make these columns a little bit wider so we can see what everything is. Very good. All right. So the average vigilance in the morning is 9.07. Average vigilance in the evening is 7.07. So on the surface, at least, it appears that vigilance in the morning is greater than it is in the evening. The question is that significant? Are we 95% correct if we make that claim? Here it gives us the variance. Variance in the morning is not exactly equal to variance in the evening. We're not going to worry about that. We have 13 observations in each. We hypothesize that there is no difference. And now here are our t-statistics. Our t-statistic is 1.677. And here we have two t-tests. One is for the one-tailed, the other is for the two-tailed. We are doing a two-tailed test. And here our p-value is 0.1065. In other words, if we claim that these differences are, or that vigilance is different in the morning and the evening, we have a 10% chance of being wrong when we make that statement. We, in biology, use a critical value or a p-value there of 0.05. So in order for us to make the claim that vigilance in the morning is different from that in the evening, that p-value would have to be 0.05 or smaller. It's not. For that reason, we are not going to reject the null hypothesis. Instead, we will accept the null hypothesis of no difference. So for these data, we would come to the conclusion that there is no difference in vigilance in the morning and the evening for this sample of gray squirrels.